So I'm going to show you about these steps in a how we do a PMI, right? But these steps are for a series, right? So I'm just going over a series PMI just for you to remember all these steps. As I said, it's a series. It is not what we do in full. We do in sequences. But I just want to do over one, right? So let's see if we can do this. Prove by mathematical induction. Let's take a look at the summation of R going from 1 to N. Let's do a simple one. R squared. Very right. Kita mix up na. All right. So let's see if we can prove it and make sure I write it correctly. N squared, N going from 1, 1, 6, N. Right. So I just going over the steps on how to do PMI. Again, this is a series, right? A series has summation. What we're focusing on today is sequences. Okay? All right, but I'm showing you one of this because you still do this as well. Because when we do series, we do the same thing. So today, technically, is just PMIs alone. Right. What's the first thing again? Right. The first thing we do is we check for N is 1, check the left-hand side. Left-hand side, N is 1 squared, which is 1. And then we do it for the right-hand side. Plug in N is 1, that'll be 1, 6 by 1 plus 1 by 2 by 1 plus 1. 2 by 3 is 6, 6 by 1, 6 is 1. Therefore, it holds. Right? Next step, we have to assume true for N equal to K. Right? So your first step, N is 1, make sure both sides equal. Well, first value here. It's not always N is 1, right? Wherever the first value here, make sure it holds. Make sure the left hand and the right hand side equal. Then you assume true for N equal to K. So all you have to do is everywhere you have N, replace the N with K. That's okay. Next step is what? After you assume, the next step is you have to show it holds for N is equal to K plus 1. So you'll end up with the summation of R going from 1 to K plus 1, R squared. So everywhere you have K, you're basically putting K plus 1. So that'll be 1, 6, K plus 1. K plus 1 plus 1, that'll be K plus 2. 2 by K plus 1 will be 2K plus 3. All right? This is the statement that we have to prove. So you really have to prove this. So you start with your left-hand side and you work it out, right? Summation of R going from 1 to K plus 1 of R squared is equal to, anybody remember this statement has come all the time? Summation of R going from 1 to K plus the K plus 1, 2. Right? When you reach here, finish it out, Emily. Right? See if we can finish out that remaining part. Right? This right-hand side here, all you have to do is make the right-hand side look like this. Are you ready? Record, no, right? So, no. So, right? So, what's the summation of R squared? Where this comes from? Comes from here, right? So that will be 16K, K plus 1, 2K plus 1. And what's the K plus 1 term? Just drop K plus 1 in here, right? So you'll get K plus 1 squared. Right? Whenever you share what to do. Everybody remember? Factorize, right? So what we can factor out here? K plus 1 and something else. We could factor out 1/6. But remember that? So if you remember from unit 1, we said write 6 on 6 here. 6 on 6 is the same as 1, right? So if I factor out 1/6, I'll be left with K. I'll be left with K by 2K plus 1 plus 6 by K plus 1. That's okay? This by this, give me back this. This by this, give me this. That's okay? And then you work it out. So you'll get 1/6 by K plus 1, and then you expand this out. You will get 2K squared plus K plus 6K is 7K plus 6. Do your little factorization. And when you do your factorization, you will end up with your answer here. K plus 2 by 2K plus 3. That's it. QED. And write your last line since it holds 4. Right? Write your last line since it holds 4. Okay. So again, these are the steps that you take. The difference in sequences now, I want to point out something, right? But when you're doing these questions in sequence, it's a little bit different. Right? So we're going to focus on sequences, right? In your sequences, it's the same major steps we do it, but you'll recognize that we're using something else here. Right? We're using something else here. We're going to use a statement that it gave us. All right. So I just wanted to do this over for you to remember the steps, right? Showing holes for the first value, assume true here, and we want to prove this, right? Right, but it's going to be a little bit different now, right? Oh. What kind of one? All right, so I want to explain what we're going to do here. So way down, the steps are a little bit different, right? Steps are just a little bit different. Right? Write the statement down and let's go through it. This module 2, yeah. This module. Ready? So when you read this here, right? You see the whole long thing here, right, Emily? What you're really trying to prove? You're trying to prove this, this. Oh, what you're trying to prove is really good. Right, so you're proving this, right? So prove by PMI. So this is what we're trying to prove. But we give on something. You see this given part here? You see that given part there? That given part is what we're going to use down here. Because this is what we know. Okay? This here is what we know. Right? So I want to show you how to solve these, right? It's real simple. Right? Once you understand that we've proven this by using this in this step here. All right, everything easy after that. So first thing first, when n is 1, let's just see what u1 is. U1 is what? They gave us that, right? U1 is a half by 1 plus 1. That's 2. 2 by a half is 1. Right? And what they told us u1 is here. They told us that. Right? So it holds because u1 is equal to 1. That's okay? There's no left hand and right hand side in this case. We just proven this, and we know that u1 is 1. That's okay? Next, what's the u to the k statement? It will be u to the k. Remember, we're trying to prove this, right? So it will be u to the k is equal to half k by k plus 1. That's okay? Ignore this until you reach here. Okay? What will be u to the k plus 1 now? U to the k plus 1 will be a half by k plus 1 by, so we're trying to prove this, right? So what do we start with? We start with what we know, right, Kivish? Yeah? Kivish? So what do we know? We know this. The question told us, given this. So we know that u to the k plus 1 is equal to u to the k plus 1. Does this look like that? Not yet. Right? So when you reach here now, what are you going to do? Substitute what? Substitute u to the k that we have here. That's okay? So this line gives us our starting point. Right? It tells us where to start the proof from. We start the proof from where we know. That's okay? And then you write down what's u to the k. U to the k is a half k by k plus 1 plus k plus 1. Expand this away. What you want to get? You want to get this here. So it's up to you. You can factor out a half and k plus 1. You'll be left with k here. And you'll be left with what here? Is that your answer? Yes. Right? So you can do a little QED, a little box here. And we'll write the statement. That's okay? So now there are two things that you have to recognize. You have to figure out what you're trying to prove and use that. And then what you have given is what you use here to begin your proof. Right? So remember, we use this to begin right? To begin the proof in this statement, right? So we use this here. That's the only thing that's different now in the PMIs. Right? It's always give you something you can start with. Book it out. Tonight, I'm going to say it. Right, you can go here. Copy down when you finish. Right done. Right? Remember all these are sequences, right? That's we can note, right? Are you paying attention, Emily? And now is the last one, Emily. All right, Upon. Do that fast. Do that quick. We had to figure out what to prove, right? And if you find it blurry, just log out and if we can tell by logging back in, right? Okay, now we'll shut your hand, you can still come to class. Okay. Right, what we're trying to prove again? Part on top or the part underneath? Underneath, right? So this is what you're trying to prove and this is what you're going to use to help you. Oh yeah. Which is like black or blue? Purple, I'm a purple. Come on, board and do it. Oh yeah, good afternoon. I think she should be trying to do that one. Sorry. Start with n is zero here, right? Because you have u zero. Yes. Right, u zero is zero, right? Right, can we get through? I see some blank spots there. You guys hear us? Yeah. So your first step is what? Your first step is that n equals to 0, right? So that'll be u0 is equal to the 0 minus 1. 1 minus 1 is 0. So therefore it holds because u0 is 0. Right? Then n equals to k. U to the k is 2 to the k minus 1. Right? Next step, u to the k plus 1 is equal to 2 to the k plus 1 minus 1. That's okay? What do we know? We know this here. So we know that u to the k plus 1 is equal to 2 u to the k plus 1. What do you substitute now? Substitute u to the k. Right? So you'll end up with 2 by u to the k is equal to 2 to the k minus 1 plus 1. So this will be 2 by 2 to the k minus 2 plus 1. 2 to the power 1. You add the powers, you'll get 2 to the k plus 1 minus. That's it. That's all. Right? Well, I didn't get that, so I'll give you one that's, I don't know. Okay.
Okay.
You questions online? Online, any questions? Now, you see now? Yeah, actually, you just look at the key message now. Video. Yeah, you can get into one. Because pay attention. By playing game. Right, let's try next one. Ready? Let's go again. Are you ready? Let's try our next one, right? Right, I just give you a little more indices to work with, right? But the same principle. Given that u to the n plus 1 please pay attention to this so you'll know where to start. They wanted to prove that u to the n is equal to 3 by 2/3 to the n minus. Try that quick. Okay. Take your time. Right, if you get it online, that's method QED, right? Yeah. This is 2u to the n minus 1, not subscript, right? And it's 3 by 2 thirds to the n minus 1. Yeah, I think that. 2 minutes has gone by, right? Right? That's the other one. All right. I'm gonna try it. That's PMI. Yeah, same thing. So, right, so when n is 1, we'll get u1 is equal to 3 by 2 thirds by 1 minus 1. This will cancel, so you'll get 1. So therefore it holds. Right? Then we become u to the k. is 3 by 2/3 to the k minus 1. And here will be 3 by 2/3 to the k plus 1 minus 1. So we're trying to prove this statement here represents u to the k plus 1. So let's start here. So this will be u to the k plus 1 is equal to 1/3 by 2 u to the k minus 1. Right? Let's see. This will be 1/3 by 2. Right? You can multiply it out one time. U to the k is what? 3. Yeah, we'll check after. 3 by 2/3 to the k minus 1. Right? That's u to the k, and then you minus in 1 again. Right? So I'm multiplying. Right? So I'm multiplying it out, right? So I'm multiplying 1/3 by 2. So that'll be 2/3 by 3, 2, 3 to the k minus 1. 1/3 by minus 1 is minus a third. Right? Let's expand out in here and see what happened. Right, nothing. So this is the true cancel. So, all right, so we don't want to cancel, right? The reason I'm saying that is because I'm watching the answer here and I see a 3. So I don't feel we should cancel. So let's just multiply and we'll get 3 by 2/3, right? By 2, 3 to the k, and this is 1. Right? 2/3 by minus 1 is minus 2/3 minus 1/3. Now I have 2/3 to the 1, 2/3 to the k. So I'll end up with 3 by 2/3 to the k plus 1, which is what I want, right? 2/3 minus 1 is minus. That's it. So the problem may have been multiplied out, right? That's why I didn't jump. I didn't jump to multiply it immediately because I recognize I want to get k plus 1. So somewhere here I have to get 2/3 to the k by 2/3 to the 1. Right? That's why I was hesitant to multiply it out. Okay? So it's important to watch and see what it proves. Right? But here what you can do, right? If you had multiply out the 3, let's just see what you end up with, right? If you had multiply it out here, you would have gotten 2 by 2 to the 3k minus 1 still, right? Which is pretty close to the answer, right? So what I would have done is I would have said, okay, I have 3 and I know I need to get out. So I would have kind of rewrite this, which is the same thing, right? 3 by 2/3 is the same as 2. And I recognize this would have given me what I wanted. So if I had reached here and a stick, I would have expanded that a little bit and just see what I need to get. And then I would have written it back. Okay? Next one. I'll try one more and then I'll give you an inequality. Any questions online? So in that particular one, just take your time and watch the solution, right? Amanda, you okay? This is 2 to the power of 2 to the n. Right? This is 2 to the power of 2 to the n. Okay? So it's a power to have a power, right? Try this one. Right? So let's confuse here. Just do it piece by piece. If n is 0, 2 to the 0 is 1. So that's 2 to the 1. That's it. Okay? Emily. Very nice. This one, please, Aaron. I take the time with the indices, right? Right, so what do we know again? We know this, right? So we know that u to the k plus 1 is 2 u to the k by 1 minus u to the k. When I reach here, Shirish, what to do? What? Which one? This? Which one? Which one is second one? What is substituting here? You can't substitute with 2 and 1, right? So what you would substitute for? U to the? So where is u to the k? Which one? First one, right? So all we're doing is we're gonna take off u to the k and write this, right? Right, so it's 2 by that, close that bracket, open bracket, 1 minus u to the k again, right? U to the k is a half by 1 minus 1, 2 to the k. Right? So if you look at it, it's looking kind of confusing. So let me try to break it down a little bit, right? 2 by a half, that's 1. So this bracket here now becomes 1 minus 1 on 2, 2 to the k. I'm not taking my eye off of what I need. Somewhere I'm going to have to factor out a half and thing. Okay? So that's that bracket here. Just looking a little too much, so I want to break up in here first. So it's 1 minus a half by 1 is a half. Minus a half by minus a what? Plus, right? That's okay? So it will be a half by 1 that minus a half by minus a half is plus. So I'm multiplying a half by 1 over 2 to the k. And I close up that bracket there. Okay with that? Okay, super. On the show. I'm going to do some magic in a little while, right? 1 minus a half is what? A half, right? So I'm going to get 1 minus 1 on 2 to the k. 1 minus a half is a half. Plus a half. I'm not trying to multiply this yet. Right. Question. This looking nice? What making this look bad? The half, right? So look at your answer. Look at this. What you can do? You can? You can add the half there. You can factor out the half, right? So if you look at your answer, right, and you look at what you have, right, just looking at a little thing, so I can factor out a half. So if I factor out a half, I will get this multiplied by 1 minus 1 on 2 to the k. I'll get that by, remember, I factor out a half. So I'll get 1 plus 1 on 2 to the k. Just looking nice up. Yeah, Emily, what is looking like? What you good? Let's keep staying. You have a minus and a plus sign here. Difference of 2 squares. Right? So that'll be a half of 1 by 1 is 1 minus this square is 1 on 2 2 to the k squared, right? What does squared mean again? Squared means I'm multiplying it by itself. So I have to find a way to work this out, right? Correct? Huh? Well, looking hard there, right? Right? This looking hard. So our objective is to simplify it as much as possible. So I remove the first bracket. And when I reach here, I factor what you have. And now you should see difference of 2 squared. Right? So when you reach here now, what to do? Right? This is the 2 to the k by 2 to the k, right? So this is 1 over. What is 2 to the k by 2 to the k? And you can add the powers. So you'll get 2 to the k plus 2 to the k, right? What is 2 to the k plus 2 to the k? No, not 4. 2 to the k. Correct? So 2 to the k plus 2 to the k is 2 to the k. And then and that's 1. Right? So this is 2 to the k. So you're going to get a half by 1 minus 1 on. That's now. Right, Tabby? 1 apple plus an example. Remember, it's 2 are the same thing. So 1 of this, technically there's a 1 in front here, right? So 1 of this plus 1 of this is 2 of this, right? 2 to the k plus 2 to the k is 2 to the k. And you can multiply 2 by 2, right? Yeah, the add the powers. Right, so this one was probably hard, right? Nice, perfect. Let's take a look at the equality. Okay with that? So the way I attempted this, right, and the way you should as well, is after you make a substitution, they try to simplify as best as they could. Right? But keep your eye on the answer. Keep your eye on the answer as a proof, right? So keep your eye on the answer. Right? When you finish, I'm gonna give you inequality. Online, any pass you to go over. So after I factor the half, I use difference of 2 squares, and I showed you how to simplify this here. 2 to the k plus 2 to the k is 2 to the k. Same base, added powers, and you get your answer. Right? How about it? Looking hard? Huh? Next one, the inequality. So you have to remember how to simplify the inequality. All right? You sure? How far have you? Yeah. Right. So it's like, yeah, but when you reach here, well, what's your answer? You had a factor or something. Yeah, I'll get all this studied out. Just studied out. All right. We have series to go on. All right, try this one. A little bit different, right? When you reach say one step, you have to turn this equal sign into inequality. So you have to remember how to do that. You got a substitution. Huh? Okay, trying to go. But do it not so on. Right? When you reach the proof part, you have to figure out how to remove the equal sign, right? When I have to watch it, we will. Right? You're doing the same thing that I've been doing all the time. I have to get rid of the equal sign. It's the last one, right? So when you reach here and you write this statement, you have to figure out how you can replace this. And the hint is in the same u to the k statement. You have to take off the equal sign to get the equality sign.
X1.
Wait, that should be less than. Sorry, this should be less than.
Is it X1 or X?
X1. Guys, come on here. And as well. And here I have VSB. And then the full stop become. All right, n is equal to 1. N is equal to 1, so x1 is less than a half, which we already know here. Therefore, it's true. Right? I mean, we saw the space here. Now we could write u to the, sorry. Now we could write x to the k is less than a half. That's okay. And now we need to prove x to the k plus 1 is less than a half. What do we know? We know this, right? We know x to the k plus 1 is equal to x to the k squared plus a quarter. We have to find a way to get rid of this and bring in an inequality sign. And again, we have to use what we know. Right? We know what u to the, we know what x to the k is. Right? Do you think? Give me a minute. We have to find a way to replace this and get rid of the equal sign. Right? The hint I could give you is this is x squared. So you have to figure out how to get out. Think about it. About 3 lines again and you're done. Right. What would be x squared? Right, so Brianna said this, right? If I were to square this and square this, the inequality sign doesn't change, right? So you will get x squared to the k is less than a quarter. What do I do now? If I put something in here, right? And I put something that is less than this. What you can say about the two sides. So if I have this statement here, right? So you have to think a little bit here, right? If I replace this value with something that's always smaller than it, what you can say about these two relationships. This side is what? This side is also bigger than this, right? Right? Okay, so let's try to use that analogy. Right? If you put something bigger, what will happen? Think about it. So if I put something here that makes this side bigger than this, then this is less than this, right? So yeah, think about that, right? So k squared to the k is less than a quarter. That's okay? Which means that a quarter bigger than this. That's okay? So if I put a quarter here, if I put a quarter here, it makes this side bigger than this side. And this side smaller than this side. So it means that this is less than this. And this smaller than this, right? So this side is less than this. So it means that x to the k plus 1 is less than does it? Right? If you remember from unit 1, you always have to make a kind of intuitive substitution. Right? Let's just pretend you had quarter there. You had to figure out what you could replace here to give you 3/4. That's okay? So you have to look out for that, right? What you can substitute to work it out. Oh, you want one more? Let me show you today. Actually, do one of one thing. Right? What we also have to do next day, we'll do the PMI. In fact, I'm not doing the PMI summation, right? I just doing one of the past one, that's it, right? But we'll move on and we'll take a look at some other things in series next week now.